said to you that concave mirror is also called as converging mirror because of its tendency to converge all the light falling on it. That is concave mirror. Convex mirror is called as diverging mirror because of its tendency to diverge all the light falling on it. Any spherical mirror will have a center from which the mirror has been derived. That center is called as center of curvature. Apart from that, the point at which the rays are converging after reflection is called as focus. The line which joins the principal that is the center of curvature, focus and the mirror is called as principal axis. Principal axis at which point it cuts the mirror is called as pole, isn't it? These things are much known to you. And then we discussed about the image formations. We came to know that as the object is approaching from infinite to focus, the image approaches from focus to infinite. That is, when the object is at infinite, image forms at focus, it is real, highly diminished, point sized, whatever. If the object is beyond C, image forms between C and F, real, inverted, diminished. If the object is at C, image forms at C, real, inverted, same size. If the object is between C and F, image forms beyond C, real, inverted, enlarged. If the object is at F, image forms at infinite, real, inverted, highly enlarged. And if the object is between F and P, image forms inside the mirror or behind the mirror, between, that is inside the mirror, and it is virtual, erect and enlarged. All these are the image formations by a concave mirror. Joshita, video should not go off anytime, okay? You are in online class, video should be on, right? So, I hope you understand whatever I have told. So, any ray diagrams can come, especially when the object is between F and P. There is where you will make mistake. So, any ray diagram comes, remember how to draw, use pencil, use scale and have a habit of keeping that is focus at some 4 centimeter, then automatically C will go at 8 centimeter and keep the object, then draw the rays. You can use any of the 4 rules. The 4 rules said that any ray passing parallel to principal axis will converge and pass through focus. Any ray passing through focus will become parallel to principal axis. Any ray passing through center of curvature will retrace its path, and if any ray is passing through pole, it will reflect making the same angle. So, out of these 4 image rules, you can use any 2 rules and make your image location. You can find the image location. Okay, it is very, very important. Question comes from here regarding drawing of ray diagrams. So, expect definitely in the question paper one question from image formation, but that diagram. Then we talked about mirror's formula, which is 1 by f is equal to 1 by v plus 1 by u. Magnification, which is the ratio of height of image to height of object, hi by ho, is equal to minus v by u for the mirrors, and based upon that expect numericals to come in the exam. For sure it will come, where they will ask you to find what is the height of the image or magnification directly or something from magnification. Sometimes they give magnification to you, you have to make relation between v and u and then put in the formula of 1 by f is equal to 1 by v plus 1 by u and get the value of f. I hope you get my point. They will give you only magnification. If they give magnification, you can find v and u relationship, because you know that 1 minus v by u is m. Suppose you got v as minus 3u, suppose. Then you can put 1 by f is equal to 1 by v plus 1 by u, instead of v you can put minus 3u. Then you get only one unknown u, and here you have the value of f, you can find u. Once you get u, you can find v. I hope you are getting my point. This kind of questions are also coming where they give you only f and magnification and they ask you to find u and v. Sometimes they do not use the word magnification. They will say like there is a mirror which is capable of producing an image 3 times larger than the object. It means magnification is plus 3. I hope you are getting my point. Again, plus 3 minus 3 we cannot say. We should understand whether it is a concave mirror or convex mirror. Then we can decide whether it is plus 3 or minus. But 3 is the value of m. How we came to know m is equal to 3? Because it is making 3 times larger. If they say there is a lens, there is a mirror capable of reducing the image size to half, it means magnification is 1 by 2. So sometimes they do not use the word magnification, rather they use some terminologies in the sentence where you should understand they are talking about magnification. Is it clear to you? Then in this chapter, we have learnt about what are the applications of mirror, where I told you concave mirror is used in many places, for example, makeup man, or for dental purposes for seeing the cavities, used as the headlights of the vehicles. Then it is used to make solar cookers, solar furnace. There are so many uses of concave mirror. Same way convex mirror, it also has uses, like it is used in parkings, at the turning points. Convex mirror is also used in where else? Near the cameras it is used sometimes to capture your photo. I am talking about CCTV cameras. These are the applications of convex mirror. Also used in rear view mirrors in vehicles. Definitely question will come where they will ask you why convex mirror is used in rear view mirror of the vehicles. Because it has larger field view. If you don't write this keyword, they won't give marks to you. It has larger field view, so it can produce image of more objects behind you, and you can see many things coming behind you, and that is the reason objects are nearer than what we see inside the mirror. That mark also is there in the rear view mirrors. Objects are nearer than how you see them, isn't it? Apart from that, then comes refraction through rectangular glass slab, where you know that if you have a rectangular glass slab, then the light which enters at an angle theta, this is called an angle of incidence. Now suppose outside is air and this is glass, then we know that light is moving from a rarer medium to denser medium, it will bend towards normal, making an angle r, and then it is once again going from a denser medium to a rarer medium, it will go away and then it will become, parallel. What happened here? Any problem? If you want to sit inside, go and sit fast, whatever, make it fast. So this is called as lateral displacement. This D is called as lateral displacement, which is the distance between the emergent ray and the path of incident ray. Always remember that a rectangular glass slab is capable of changing the path, not deviating it, but displacing it. Deviation is different from displacement. Deviation means the angle I and angle E will not be same, it will be different. So in this case, angle I is always equal to angle E. If the first medium and the last medium are same, angle of incidence will always be equal to angle of emergence. Also you should know, we have learnt about refractive index. What is refractive index? It is a ratio of speed of light in vacuum to speed of light in any medium. So if I say refractive index of some like for example, refractive index of glass is 1.5. It means speed of light is 1.5 times slower in glass compared to vacuum. Again a common question comes in the examination. What do you mean by refractive index? Refractive index is the ratio of speed of light in vacuum to speed of light in a given medium. It gives an indication of how much the light will bend in the medium. I hope you get my point. And refractive index is of two types. One is absolute refractive index. Absolute refractive index means you are comparing the refractive index of the medium with vacuum or air. And if you are comparing refractive index to two different mediums, it is called as relative refractive index. For example, if I want to write refractive index of one medium, it will become N1, it will become C by V1, isn't it? If I write refractive index of second medium, it will become C by V2. But if I want to write refractive index of first medium with respect to second medium, which will become equal to refractive index of first medium by refractive of second medium, you will get C by V1, C by V2, CC gets cancelled. So N12, which was equal to N1 by N2, will become equal to V2 by V1. This is the formula of relative refractive index by which you can find refractive index of two different mediums. For example, if I give you refractive index of water is 1.33 or 4 by 3, refractive index of glass is 3 by 2. What is refractive index of glass with respect to water? This kind of question will surely come in the examination and you have chance of doing mistake in this. If they ask you what is refractive index of glass with respect to water, it means I will write refractive index of glass divided by refractive index of water, which will become equal to how much? 3 by 2, 4 by 3, which is equal to 9 by. Are you getting my point? If they would have asked you what is refractive index of water with respect to glass, it will be NW by NG, which will become equal to 4 by 3 by 3 by 2, which will become equal to 8 by 9. I hope you are getting my point. This kind of questions will come, where they may give you refractive index of two different mediums and they may ask you relative refractive index between them. Be very careful about it. One more important thing I want to say you, please pay attention. When a light is travelling from one medium to another medium, when light is travelling from one medium to another medium, its wavelength changes or not changes. I am asking you whether wavelength will change or not. When light is travelling from one medium to another medium, whether its wavelength changes, velocity changes, frequency changes, frequency. So, frequency will also change. Let me tell you now, this question comes in the exam very frequently. Whenever light goes from one medium to another medium, velocity definitely changes. That is what refraction is all about. Refraction says that in rarer medium it is faster, in denser medium it is slower. So, if medium is changing, velocity will certainly change. If medium is changing, wavelength will also change. Answer Nitish, it will change. What does not change is frequency, because frequency is source dependent. I have told this in the class when I taught it, isn't it? I am repeating it once again. Write down somewhere, this question has come in the exam many times. If a light is passing from one medium to another medium, what remains constant? What remains constant? Frequency remains constant, because frequency means color, if you do not know. Blue has different frequency, red has different frequency, green has different frequency. If I am passing blue light, blue will not become red, blue will remain blue only. It means frequency remains same. But since the velocity is changing, wavelength must change, because in 9th you studied velocity is equal to frequency into wavelength, am I right? If frequency is constant, velocity is changing, it means wavelength must change, no option it has. Are you getting what I am trying to say? It means, remember this thing, that when light is going from one medium to another medium, what remains constant is frequency, what changes is velocity and wavelength. Expect this question to come in the school exams. Okay. One more question comes very frequently. If I put a mirror in water and if I put a lens in water, whether its focal length will change or remain constant. I am putting a mirror inside the water. Mirror has a focal length of suppose 20 centimeter. If I put the mirror in water, whether its focus will change, focal length will change? No or yes? No. Okay. If I am having 10 centimeter of focal length of lens, I am keeping the lens in the water, whether its focal length will change? So, whether change in medium affects focal length of mirrors and lenses, that is the question. Whether change in medium for both.
Sir, for lenses, because refraction might differ.
In mirrors?
Mirrors,
no. That is the answer. Remember this. Whenever light is going from, whenever the medium around the mirror is changed, its focal length does not change. But whenever the medium around a lens is changed, its focal length changes. So, if I am having a lens, its focal length is 10 centimeter. If same lens is kept in the water, it will not remain 10 centimeter, it will change. You will learn it in higher classes that the focal length of the lenses depends upon its refractive index. The formula is there. 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. Leave it, it will come in the higher classes. But that formula tells you that refractive index and focal length are related for lenses. But if you see mirrors, you know that f is equal to r by 2, isn't it? Do you know this thing? That f is equal to r by 2 cannot be used for lenses. If you do not know this thing, now I am telling you. R by 2 is f, isn't it? Only for mirrors. Do not use it for lenses, not valid. F is not r by 2. F has a different formula. F and R have different relationship. F is equal to, actually it's not F is equal to, 1 by F is equal to mu minus 1 into 1 by R1 minus 1 by R2. Not required for, don't write this, not required for you because it is in 12th standard only. But that's how focal length and radius is related. It depends upon the refractive index of the medium. But in this case, there is no refractive index involved. It means, as I asked the question, if mirror is kept in a liquid, its focal length will remain same. But if lens is kept in a liquid, its focal length will change. It will decrease actually. Okay, fine. Then we have to learn about concave lens and convex lens. I have said this to you earlier also, once again I am repeating that convex lenses have similar behavior to concave mirror and concave lenses have similar behavior to convex mirror. That is, concave lens is a converging lens, ulta I am saying, diverging lens, and a convex lens is a converging lens. Whereas concave mirror was a converging mirror and convex mirror was a diverging mirror. But in lenses, convex lens is a converging lens and concave lens is diverging lens. Converging lens means it has a property that whenever light is falling on it, it will converge it to what? One point like this. This is the property of which mirror? Which lens? Convex lens. That's why convex lens is called as what lens? Converging lens. Same way, if you have a diverging lens and light falls on it, it means a concave lens. It has a tendency to diverge all the light coming on it, and that's why it is called as a diverging lens. The concave lens is called as diverging lens. Remember this. Okay, and once again, all the image formations of a concave lens and convex lens should be in your head. It will come in the examination. Draw the ray diagram. So, if the same like concave mirror, convex lens, if the object is at infinite, image forms at focus, real, point sized. Object is beyond 2f, image forms between f and 2f, real, inverted, diminished. Object at 2f, image at 2f, real, inverted, same size. Object between f and 2f, image beyond 2f, real, inverted, enlarged. Object at f, image at infinite, real, inverted, highly enlarged. Object between f and o, image on the same side of the lens, virtual, erect, enlarged. For concave lens on the other hand, wherever you keep the object, image always is virtual, erect, diminished, and forms between O and F on the same side of the object. Okay, all these ray diagrams, please practice well for your school examination. Out of all the ray diagrams of lenses and mirrors, something will come for the exam, one or maybe two. So, it should be very clear in ray diagram. Don't make any mistake. And whenever you are making a ray diagram, I am repeating, use pencils and use arrow marks. They will cut marks for arrow also. Suppose they are asking you, draw the ray diagram for a convex lens, object is kept between f and 2f. So, you will draw like this, isn't it? There is f1, 2f1, f2, 2f2, and you will keep the object somewhere here like this. Then you will pass one ray, converge it and make it pass through focus. Second ray will pass through optical center undeviated, goes and hits here. This is the image, isn't it? So, you will write here A, B, you write here A dash, B dash. If you don't put these arrows, expect them to cut your marks. They will cut. So, arrows are equally important than other things. And always mention the optical center in the case of lenses. Always mention the pole in the case of mirrors. Don't confuse this. I have seen many students writing pole for lenses. No, lenses does not have pole. Lenses have only optical center. And optical center is that point from where the ray goes undeflected, undeviated, straightly it goes. At every other point, rays will bend. If they pass through optical center, it goes straight. I have even explained you why in the regular class. Okay, coming back. So, all the ray diagrams are important. Then comes the lens formula. Lens formula is 1 by f is equal to 1 by v minus 1 by u, and magnification, which was Hi by Ho, is going to be plus V by U. The word magnification itself means that it is the ratio of height of image to height of object, and in the case of mirror's formula it was minus V by U, in the case of lens formula it is plus V by U. Okay? Never forget this, it is very important, magnification. And in the class I remember I have even tried with you many things where I told to you, if I give the magnification and if I ask you, you should be able to tell me what lens or what mirror, object position, image position and everything. You can tell. For example, if I say magnification is plus 3 and if I ask you what lens is used, what will be your answer? Plus 3. Concave or convex? Concave. Concave can never produce enlarged image, right? Then how 3 is enlarged? Again I am repeating this, guys, those who are not knowing it. Whenever magnification is written, that is plus or minus some number A, this plus or minus represents whether it is a real image or a virtual image. If it is plus, it is virtual and erect. If it is minus, it is real and inverted. This number A can have 3 possibilities: being more than 1, being less than 1 and being equal to 1. Once again I am repeating, you should only take its magnitude, okay? Never take minus 3 means less than 1 only, no. 3 only should take, minus separately you should take. Are you getting my point? If you see, if I write magnification is minus 2, sir, minus 2 is less than 1, so it is diminished. No, minus should be taken separately and 2 should be taken separately. If I write minus 0.2, yeah, less than 1. But minus 2 if I am writing, minus denotes it is real inverted. 2 denotes it is more than 1. More than 1 means what? Enlarged. Less than 1 means diminished. Equal to 1 means same size. So when I gave the question m is equal to plus 3, it is very certain that the image is virtual, erect and enlarged. Only possibility is a convex lens, image produced on the same side when the object was kept between F and O, isn't it? That should click in your mind. I hope you are understanding this. If I write m is equal to minus 1, which lens? Which position of object? Very good, object at 2f. Object at 2f, image at 2f, same size. 1 means same size, minus means real and inverted. I hope you are understanding this. If I say m is equal to plus 0.25 in mirrors, comment, plus 0.25 for mirrors, plus means virtual erect, 0.25 means diminished, so virtual, erect, diminished, convex, mirror, and where is the, anywhere the object can be, it will form always inside the mirror. Okay. If I say m is equal to plus 1, plane mirror, it cannot be concave or convex, because virtual, erect, same size, no mirror can produce, no lens can produce, virtual, erect and same size. Are you getting my point? Virtual, erect and inverted is possible, that is, sorry, real, inverted, same size is possible by concave mirror, object at C, but not possible plus 1 for any mirror. So it must be a plane mirror. This kind of questions can come where they may ask you to find type of lens, type of mirror, object position, image position, just by giving you magnification. If you have clarity on this topic, you can answer it. If you don't have the clarity, you will make a mistake. Then comes power. What is power? Reciprocal of focal length, and F should be in meters. P unit is diopters. So if I say power of a lens is plus 2 diopter, What kind of lens is used in the spectacles? What will be your answer? +2 diopter. F is plus, whether it is convex lens or concave lens. Convex lens. I hope you should know that for a convex lens, focal length is positive. For a concave lens, focal length is negative. These things, if you are not remembering, then very bad. So when I am saying plus, it means it is a convex lens. So it's a convex lens. If I say power of a lens is -5 diopter, what lens they are using? Concave lens. Of what focal length? Easily you can find. So what you will do? You will write P is equal to 1 by F. 1 by F is equal to -5 plus whatever, -5. So F will become equal to -1 by 5 in meters. To make it simple, I will multiply by 100 to make it centimeter. So -100 by 5 centimeter. So it will become how much? -20 centimeter. So focal length is how much? -20 centimeter. Are you getting my point? This kind of questions can come. Or question can come from the combination of power. That is, if you have a lens, you have another lens nearby it. It has focal length of +20 centimeter. It has focal length of -10 centimeter. What is the combined power? How will you solve this question? Power of combination is equal to P1 plus P2. Am I right? So PC will become equal to 1 by F1 plus 1 by F2. So when you solve this, you will get the answer of combination of power. F1 and F2 are known to you. If you are weak in solving fractions, addition, subtraction, then gone. Light chapter itself is gone for you. Because whatever numericals are going to come, we will have only fractions involved here. Right? That is all about light chapter. Yes, loudly. Shall I talk about human eye then? Is light clear to you? Already light, last class also I revised light only. So let us take one question before I start here, human eye revision. Question number 24. I have also sent you a worksheet in the group. I don't know how many of you minded it. I told you it will be helpful for you for the upcoming board examination. Sorry, upcoming school examination. Question number 24 I am talking about. Question is, draw a ray diagram to show the nature and position of an image formed by a convex lens of power plus 0.1 D when an object is placed at distance of 20 centimeter from its optical center. What is that? Sorry. I want it not to be there. I am talking about question number 24, okay? Is it visible to online people? Online people, is it visible to you? I hope it is visible to you. I am talking about question number 24. Please solve it. Half it is here and half it is there, okay? 24, please solve it. Let me know if you get some answer. Any answer? I hope you are getting the question, by the way. It's a convex lens question, right? And its power is 0.1 d. It means what is the focal length? Hint is focal length is how much? 1 by p, 1 by 0.1, isn't it? To find in centimeters, I will take 100 above. No, not required in this case. One second. The formula of power is what here? Power is equal to 100 by f in the case if I want to find the answer in centimeter. Yes, I was right only. So, f will become equal to 100 by p, 0.1. Oh my god, 1000 centimeter focal length. Did it come same for you? It is very unusual. Oh my god, how will you plot it in the diagram? 1000 centimeters, almost 1 meter. Okay, no issues. Oh no, 10 meters. 10 meters of focal length. Great. There is some mistake in this, it means. It cannot be plus 0.1 then. It should be 1D at least, or 10D. Anyhow, we got the value of focal length is how much? 1000 centimeters. So, we have the value of f known. What is the value of u? Minus 20 centimeter. Cannot you find the value of image? But they are not asking to find it through solving. They are asking draw a ray diagram to show the nature and the position of an image formed by a convex lens. Anyhow, if I take p as 1 by f also, which is 1 by 0.1, I am going to get 10 meters only. There is a mistake in the question, maybe printing mistake, whatever it may be, but we have the value of focal length. So, focal length is going to be 10 meter or 1000 centimeter, whatever you want to call it. And then you have u, you can find v easily. 1 by f is equal to 1 by v minus 1 by u. And put the value of u and f, you will get the value of v. Once you get the v, you can draw and show in the diagram. See, whatever, cold or hot, whatever. Shall I proceed? You can solve and get the answer. The concept is clear to you? Is the concept clear to you? One question is there. How is the virtual image formed by a convex lens different from that formed by a concave lens? Simple question. How is the virtual image formed by a convex lens different from that of a concave lens? What is the answer? Yes, for? Correct. It will be enlarged for convex and diminished for concave. Under what conditions do a convex and a concave lens form virtual image? For concave lens, anywhere. For convex lens, if the object is between F and O. See, these questions are simple if you understand how they are asking you. Otherwise, it is hell only. Okay, anyhow. So, let me come back to human eye revision. Okay. In human eye, the first thing is knowing about each part of the eye. I hope you can read by the book by yourself. Kritikeshwaran, when you came here to meet itself, I told you the video should never go off.
Sir, there is no current here, sir.
No current means how you are attending the class?
Sir, if I turn on my camera, the
Darkness will
network, it's showing that network bandwidth slow.
You are too smart, Kritikeshwaran. You are not smart actually, you are trying to be smart. I will speak to your mother after the class. Okay. Huh?
Sir,
He is a thief.
no, he's a pathetic guy. Why are you?
Pathetic means? Okay. We will speak about that later. Okay, human eye. So, in human eye, after knowing about each part of the eye, we have to understand also about defects of eye, from where the questions are going to come for sure in the examination. So, basically there are 4 defects, out of which 2 defects are asked usually in the examination. One is myopia, another one is hypermetropia. Myopia is also called as short sightedness or nearsightedness. What is the meaning of nearsightedness? Cannot see far. Nearsightedness. You have nearsightedness. You don't have farsightedness. And what is hypermetropia? Farsightedness, also called as long-sightedness, whatever you call it. Hypermetropia, also called as long-sightedness. It means you have good vision for long, but poor vision for short. So, if you are not able to see far, you are having myopia. If you are not able to see near, you are having hypermetropia. If you are not able to see both, you are having presbyopia, isn't it? So, we understood that myopia is a condition when we are not able to see far objects, far things, and we are able to see near things. How it is caused? The question comes from there only. How myopia is caused? There are 2 reasons for that. What are 2 reasons? I have told in the class. One is elongation of eyeball. Eyeball became more elongated. It happens by birth. Sometimes a child, eyeball itself may be of a bigger size. What will problem if it is that if the eyeball is bigger, then there will be a lens here, light is entering and it is converging before the retina itself. Retina is the part where the image forms. My ray is getting converged before retina itself. This problem is myopia. And why it is happening? First thing is excessive elongation of eyeball. Excessive elongation of eyeball. Second reason can be there. Sometimes the eye lens can have too much curvature, making a shorter focal length. Second reason can be too excessive curvature, or I should say, curvature of eye lens, making focal length shorter, It means your eye lens is having capability of converging before itself. Are you getting a point? You are having eye and the light, because of more curvature of the lens, it is converging before itself. This defect is called as what? Myopia, where rays are joining, or I should say meeting, before the retina itself. Same way, what will happen in hypermetropia? In hypermetropia, ulta of this, that is, your eye is there and the rays are forming where? Behind your eye retina. So, how it can happen? Shortening of eyeball. Some people by birth, defect will be where they have shortened eyeball. If the eyeball is short, then what will happen? The rays will form behind, rays will meet behind the retina, and that causes a defect in vision. Next reason can be what? Focal length is too long. Here focal lengths are short, right? Here the focal length will be long. So, you have less curvature of the eye lens. So, the lens of the eye is having less curvature. So, whatever ray is forming, before it converges, it is crossing the retina. See, convex lens has a capability of converging the light behind it, isn't it, at the focal length. If your lens is capable of converging exactly at retina, your eye is healthy. There are two problems. One is it may converge too early because of having excessive curvature power, myopia will come. If it is having less curvature power or less curvature, it will converge behind the retina. Then also hypermetropia can come. So, these are the two reasons of myopia and hypermetropia. Directly they will ask in the examination. Directly they will ask in the school examination, what are the causes of hypermetropia or what are the causes of myopia. Next thing what they will ask is, how do you correct it? So, it is common sense. If you want to correct myopia, I want to make my rays go and form the image at retina. So, I want it to get diverged. For diverging it, what do we want to use? Concave lens. So, when the ray is coming, it will diverge it here. After diverging it goes like this. So, now it is going to converge exactly at retina. So, suitable focal length concave lens is recommended if you want to solve the problem of myopia, because concave lens which are diverging have a tendency to diverge the rays coming and making it to converge at the retina of the eye. Same way, here your eye is converging it behind the retina. If I put a convex lens in front of it, it will converge before itself, isn't it? Now, it may converge at retina. So, in the case of hypermetropia, we are going to use a convex lens. In the case of myopia, we are going to use a concave lens. In school examination, expect them to ask the causes of myopia or hypermetropia and the correction for it with diagram. So, I have drawn the diagram also, rough diagram, you can draw it neatly in the examination. So, remember the diagram, remember the lens used, do not write ulta lens. So, if I ask you power of a human eye is, or power of the lens used for a human eye is plus 2.5 diopter, what defect he is having? What will be your answer? Plus means which lens? Convex lens. Convex lens means which defect? Hypermetropia. Just by knowing the power, you can judge whether he or she is having myopia or hypermetropia. What is presbyopia? Combination of both. There are some people, because of age, because of the weakening of ciliary muscles, we may get both myopia and hypermetropia. In that case, we will have difficulty in seeing far also, difficulty in seeing near also. For them, what lens is recommended? Bifocal lens. Bifocal means you will have upper part as what? One lens and lower part as some other lens. This is called as bifocal lens. Bifocal lens is recommended for people having presbyopia. There is fourth defect, I have talked about that, astigmatism. Astigmatism is when a human being is not able to distinguish between horizontal and vertical lines. So, suppose I am drawing lines like this, vertical, horizontal. How he will see, you know, he will see like this. If a person is having astigmatism, they will not be able to distinguish between horizontal line and vertical line. This defect can be corrected by cylindrical lenses. Okay. Apart from that, we have cataract, which is done by laser therapy and removing the fog formation. So, they will remove that fog from the eyes, your eyes will become fine. Cataract, I hope you know that. Again, with age we get that. Mostly old age people will get a cataract problem, which can be cured by going to the hospital and removing that fog formation by laser therapy. They are using laser therapy for that. Okay. In this chapter, we also have to talk about refraction through a triangular prism from defects of eye. Okay, we will take some numerical.
Sir, no, sir, how to solve it?
So, I will take some numerical and help you, know. So, let me take some numerical, then I will able to help you. Any numericals there here? Yes, check. 16th question. The near point of hypermetropic person is 50 centimeter. What should be the focal length and power of the lens used by him if he wants to read newspaper 20 centimeter away? Everyone try this, I will help you if you are not able to solve. Try it. So, they have given.
Sir, no, sir. I want to know the basic understanding. Why we need to take object distance as the newspaper newspaper centimeter, and then why we need to take the
Focal length as.
near point?
I'll talk about that. I'll talk about that. Okay.
V, why we need to take V as given always?
I'll
And Q as the
understood. I'll talk about it. First, you solve this question. Give a try. All of you can give a try. I'll help you. When I explain this question, no, you'll be able to understand why we are taking that near point and far point. Okay. First, you try this question. Everybody. Again, this question comes in the examination. Near point is given. What is the meaning of near point, by the way? Near point and far point. A healthy human eye has near point of how much centimeter? 25 centimeter, also called as least distance of distinct vision. And what is the far point? Infinite. This is called as the near point, which is 25 centimeter for a healthy eye, and infinite is the far point, which is infinite for a healthy eye. It means a healthy eye can see anything from 25 to infinite. If it is before 25, you will have some blurred vision. After 25, anything you can see, clearly you can see, if you are having a healthy human eye. If these points gets disturbed, then you get myopia or hypermetropia. Like in hypermetropia, you can see in the question itself, you realize the near point gets affected. So always remember, if near point gets affected, what you get? You get hypermetropia. And if far point gets affected, you get myopia. Okay. So near point of the eye has got affected, and how much it has become? Instead of 25 centimeter, it has become 50 centimeter. Now what they are asking, what should be the focal length and power of lens used by him if he wants to read a newspaper 20 centimeter away? So use 20 centimeter given. They are asking you what should be the focal length of the lens. Think and tell me, give a try, I will help you. I will take attendance meanwhile.
Sir, the near point is 25 centimeters, sir. For a healthy eye, why he wants to place the newspaper at 20 centimeters, sir?
Why he wants to?
Place the newspaper at 20 centimeters, sir. He can place at 25.
Yeah, he can. He after he gets lens, he wants to overutilize the power of lens.
Sir, this is too much of using the feature.
Yeah, maybe.
Yeah, sir.
What you're saying is genuinely correct. What will take the value of u here? Minus as u. Okay. What is the value of v here? Okay. So image was forming at 50 centimeter. you are making it to form at 20 centimeter. Sorry, object is 20 centimeter, you are going to find the focal length. Okay, yeah, that is another way of solving this question. I mean, we are not even thinking about how we are correcting this problem of hypermetropia. What we are doing no here, in this question they gave the object is kept at 20 centimeter and a human near point has got 50 centimeter. It means for him the image is forming where? He can see clearly only at 50 centimeter. So, final image should form at 50 centimeter for him to see clearly, right. So, u is taken as minus 20 here, v will be taken as, then you can find the value of f accordingly. How much is the value of f you are getting? 100 by plus or minus? Minus or plus? Should be plus, check your answer, because it is hypermetropic eye. You must have a convex lens and convex lens must be having positive focal length. Check your calculation. Again I am repeating how the question has to be solved. In this case, they have told that he has least distance of distinct vision as 50 centimeter. It means he can see only at 50 centimeter clearly, but the object is kept at what centimeter? 20 centimeter. So, he wants to make the object to form the image at what distance? 50 centimeter, because then only he can see clearly. So, object distance will be taken as 20, v will be taken as 50, and for that you can find the value of f. This question is simple, but what you are asking Nitin Raghav is different. What you are asking is, if you have a hypermetropic eye and if you are going to place some focal length for that eye, what formula to be used? That's the thing you are asking, that kind of question. Okay, we will solve, maybe not now I have in this paper. Next class I will bring some questions of that category and solve with you. With question only I can make you understand why we are taking v as minus 25 or why we are taking u as minus 25. In different scenarios we will use different values of near and far point. Why and how I will tell you in the next class. Okay. So, guys, time is 7 p.m. and everybody please remember that if you are having upcoming examinations, you must solve the worksheet entirely before attempting your science test. Only then you will have confidence of getting a good mark. If you have any doubt, feel free to ask me anytime. Okay. Attendance I have taken for the people. You can move. You are Sudhish, right? You are Santosh and you are Kamalesh, right?
Sir, I have a doubt, sir.
Ask me, man, Kritikeshwaran.
Sir, what can be the cause of loss of color vision?
Loss of color.
Color vision.
See, in our human eyes, we have something called as rods and cones. Not only human eyes, in every eye which can distinguish the color, we should have rods and cones. They are the cells in the eye. If you have defect of rods and cells, cones in the eye, then you will have defect in the color vision. You will get color blindness.
Sir, then how the glasses are made, sir?
Glasses are made for that. In special, we will not make special glasses. In special glasses, we will add some spectrum for you to see the colors well. There is no cure of color blindness. You do some surgery and you have to implant some rods and cones in your eye lens. Then only we can clear the defect of color blindness. Are you getting Kritikeshwaran? Color blindness is because of deficiency of rods and cones in the eye cell. Okay? Okay.
Okay, sir. Thank you, sir.
Take care, take care. If everybody is clear, you can drop off the meeting. Bye-bye, take care.